Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to study the energy difference between the different orbits. For calculating the energy difference, first of all we need to calculate the energy of each orbit. So for an example, I have taken here over the three orbits. The plus Z is the nucleus, and after that I have taken as an example to be the first orbit. Let this is the first orbit with n equal to the 1. The next, this is the second orbit, let n equal to be to 2. And the third one, let take this orbit infinity away from the nucleus. So now let's first of all calculate the energy of the first orbit, second orbit, and the orbit which is infinity distance away from the nucleus. Now in the previous lecture, I have derived the formula for the energy of the orbit, energy of electron in the orbit, and that formula was energy of nth orbit is equal to the minus 13.6 z square by n square, where z was my atomic number, and my n was orbit number. As we all know, as the orbit number increase, the energy of that orbit also increase. So let's calculate it. For the first orbit, let's calculate the energy. So the energy of the very first orbit comes out to be minus 13.6 z square. Now substitute the value of n to be 1. It comes out to be 1 square. So the energy of first orbit comes out to be minus 13.6 z square. Now let's calculate the energy for the second orbit. So the energy of second orbit comes out to be minus 13.6 z square divided by n. Was the value of n is the second orbit, so let's substitute the value of n to be 2. So it comes out to be 2 square. So the energy of second orbit comes out to be minus 13.6 z square divided by 2 to the 4. This comes out to be 4. So the energy of second orbit comes out to be minus 3.4 z square. Now let's calculate the energy for the orbit infinity distance away from the nucleus. So the energy of orbit in infinity distance away from the nucleus comes out to be minus 13.6 z square divided by infinity square. So the energy of orbit infinity away from the nucleus comes out to be 0. So here I have calculated the energy of first orbit, the second orbit, and the orbit infinity distance away from the nucleus. So now let's calculate the energy gap between the second orbit and the first orbit. So let's calculate the energy gap, that's the delta E, between the second orbit to the first orbit. So this will be equal to the energy of second orbit minus the energy of first orbit. The energy of second orbit came out to be minus 3.4 z square. So this was minus 3.4 z square. The energy of first orbit, it was minus 13.6 z square. So it comes out to be minus 13.6 z square. So it comes out to be minus 3.4 z square plus 13.6 z square. So this difference comes out to be 10.2 z square. So the energy gap between the second orbit to the first orbit is 10.2 z square. So now let's calculate the energy gap between infinity orbit and the second orbit. So energy gap between the infinity orbit to the second orbit, it comes out to be energy of the orbit infinity distance away from the nucleus minus the energy of the second orbit. So what's the energy of the orbit infinity distance away? It's a 0. So I'm substituting the value of 0 over here. And what's the energy of second orbit? Is 3.2, oh sorry, minus 3.4 z square. It's minus 3.4 z square. So this value comes out to be plus 3.4 z square. So the energy gap between the infinity orbit to the second orbit comes out to be plus 3.4 z square. And you can observe that the energy gap between the second orbit and first orbit is higher than the energy gap of infinity to second, that is 10.2 z square between the 2 to 1 and plus 3.4 z square between the infinity to 2. So let's find out a relationship between these two energy differences. Let me find a ratio. So I am taking the energy gap of second orbit to first orbit divided by energy gap of infinity orbit to second orbit. This answer came out to be 10.2 z square divided by infinity to second comes out to be plus 3.4 z square, and this comes out to be 3. So that means the energy gap of second to the first orbit is 3 times the energy gap of infinity to second orbit. So it proves that this thing proves that the energy gap of the energy gap of successive orbits decrease as the orbit number increase. So that was the topic for today. Now let me show you the exact orbit diagram of the atom. So it comes out to be this. You can see that this is the first orbit, the n equal to 1. This to be the second orbit, and this to be the orbit infinity away from the nucleus. Now you can observe that the energy gap between the second orbit and the first orbit, and the energy gap between the second orbit and the infinity orbit. So energy gap between the second and the first is 3 times the energy gap of infinity and the 2. So as the orbit increase, the energy difference between the orbits decrease, due to which the orbits come closer and closer and closer to each other. Here is the third orbit, then here is the fourth orbit, then fifth, sixth, and so on, and the orbits becomes continuous to each other. They are very closely placed to each other. So this is the topic for today. So I hope you all understood today's lecture. If any student wants to book a paid online one-to-one class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.